Hello there and welcome to a brand new lesson. This is how Bio Numbers where we learn maths the easy way. In this lesson, we are looking at partial fractions case 2. And case 2 talks about repeated linear factors. By the end of this lesson, you should be able to identify when a denominator contains repeated linear factors. You should be able to understand the correct decomposition form for repeated factors. To be able to decompose proper fractions with repeated linear factors. And finally, to be able to solve for constant using the substitution and the equating coefficient. On the left hand side are the answers to the previous trial exercises, that is from case 1. If you're able to do it, you can compare it here to check for your accuracy. Now, as this lesson continues, you hear me use vocabulary such as the repeated linear factor, the decomposition rule, and then equating coefficients. This is simply an explanation to them. We used them in our previous lesson, and you can pause and quickly take a glance. Without much I say or do, let's quickly look into it. So the question one might ask is, when do we use case 2? If you went through our previous lesson, you realize that we had something like p of x. Then we say all over x minus a and then an x minus b. Now these two are distinct factors. They are distinct linear factors. This one we have here is different from what we have over here. But if it appears that one of them repeats or both can repeat, you see, so if there's any repetition, such as let's say you got another x minus b, then even though they are linear factors, we would categorize them as repeated factors. You see, so this is alone whilst this is being repeated, and hence it can be written as p of x all over x minus a and then the x minus b all squared. This is when we then move from case 1 to case 2. So the rule for case 2, or the rule for repeated factors, simply says when you are expanding, your partial fraction should include terms of every power of the repeated factor. What does this mean? So let's say if we have x minus a raised to the power, let's start with a 1. When expanding, it should include x minus a. So this is also to the power 1. Instead of to the power 1, if we had to the power 2, then it simply means that it should first of all include to the power 1 and then also include x minus a to the power 2. You see, if it is to the power 3, then it should include to the power 1, to the power 2, and also x minus a to the power 3. That is what happens, you see. So if we are to limit ourselves just to the power 2, then for p of x over x minus a, then x minus b all squared, this we have here is a linear factor, you see. So it takes a over x minus a. That is, this has been catered for. Now when we come to the repeated factor, we'll take a b and it will be x minus b to the power 1. And you know, for 1 we don't write. Then we introduce another constant, a c, which you take to the power 2. If there was to the power 3, then we'll introduce another constant, d, which would be to the power 3. So with the number of repeated factors you are going to have the same number of terms. This has 2 repeated factors. So we've got what? 2 terms with increasing powers for each of the factor. You would get to understand it more if we start solving questions. So for the general method, anytime we are given these questions, we have to first of all write the decomposition form correctly. If you're able to rewrite the decomposition form correctly, then you are 80% done. The rest is just applying your knowledge on fractions, algebra, substitutions, and then change of subject. Then you'll be good to go. So without much, I say, let's quickly solve some questions to enhance our understanding. So looking at our first question we have here, it says we have to decompose x plus 3 all over x minus 1, then x plus 2 all squared. So we need to first of all write the decomposition form with the correct number of fractions for each repeated factor. That is step 1. So we have our x plus 3 all over the x minus 1 and then x plus 2 all squared. So that is going to be equal to a. Since x minus 1 is not repeated, we have a over x minus 1. Then we have plus. For the repeated factors, we'll first of all take our b over x plus 2. So the first repeated factor, and then plus c over x plus 2 all raised to the power 2. So with this, you are 80% done, as I said. The rest is up to you to take your time and then solve. Now, in our previous lesson, we looked at the cover-up method and the method of undetermined coefficient. As I said earlier on, the cover-up method doesn't always work for all the cases. It can only solve some of the constants for you, but not all of them. Meanwhile, the method of undetermined coefficients can do all that. Now, for this lesson, we'll tweak it a little by introducing an early substitution that will give us the values of some of the constants. So the first thing we need to do is to clear the denominators. And clearing the denominators, we know for the left-hand side, we will be left with x plus 3. That is, if you multiply this whole thing by the LCD, which is this we have here, it will just cancel itself out. So x plus 3 is equal to, we have a, then x minus 1 cancels out x minus 1. And below it, x plus 2 all squared. We have a into bracket x plus 2 all squared. Then we have our b into bracket. This x plus 2 takes out one of the x plus 2. Illustrating it, we have x minus 1 and then x plus 2 all squared. X plus 2 all squared is simply x plus 2 and then x plus 2. We are dividing it by x plus 2. So what happens? This cancels out this and we'll be left with these over here. So we say x minus 1 and then x plus 2 and then plus our c. For c as well, x plus 2 all squared cancels out x plus 2 all squared. And we'll be left with x minus 1. So this is what we have left after clearing the denominator. Now we can solve for a and c, you see, using the substitution method. What do I mean by that? Evaluate such that all this becomes 0. Now, if it is a we want to solve, let's evaluate such that all of this becomes 0 and then all of this also becomes 0. If it is c we want to solve, let's evaluate such that all of this becomes 0 and then all of this also becomes 0. How do we do that? If we want to solve for a, then if x here is to be equal to 1, that is, if x minus 1 is to be equal to 0, then our x is simply equal to 1. If you substitute this 1 here, we are going to get this bracket being 0. Now, if this bracket is 0, it multiplies this to give us what? 0. 0 multiplies b to also give us 0. And the same thing applies here. We have 1 minus 1, which gives us 0. The 0 times c will give us 0. So if you're able to substitute x equals 1, we'll get all of this here being 0, but then the a doesn't become 0. You see? So let's do that and see what is going to happen. So we would say put x to be what? 1. or let's let x be equal to 1. Now, if x is equal to 1, then for our left hand side, we have 1 plus 3, which is equal to a into bracket 1 plus 2 all squared. We know what happens when x is equal to 1 here. It will give us 0, you see, just as I've said. So with this, we can evaluate it as 4 is equal to a into bracket, this is a 3 all squared. Simplifying further, we have our 4, which is equal to a 9a. Solving for a simply means our a is what? A 4 over 9. You see, so with this, we have easily gotten our a. Now, we can also solve for c as well. That is, looking at this bracket here, we can equate x plus 2 toward 0. And that would mean x is equal to negative 2. So if you had substitute x to be negative 2, this here gives us 0. And this also gives us 0. But then it doesn't affect this. You see. So this time around, let's let x be equal to a negative 2. So from the left hand side, we have a negative 2 plus 3, which will then be equal to c into bracket negative 2 minus 1. Simplifying, we have negative 2 plus 3, which gives us a 1. So 1 is equal to negative 2 minus 1, gives us a negative 3. So we have negative 3c. And hence, making c the subject, we have c, which is equal to a negative 1 over 3. So just by simple substitution, we've had our a and then our c. We can't use this substitution to solve for b as well. No, we can't do that, because if we let x to be equal to negative 2, it will affect this, and then b would become 0. As in, this second term becomes 0. If we let x to be negative, if we let x to be 1 as well, it will also make this 0. So this is where we now rely on the method of undetermined coefficients. So with the method of undetermined coefficient, what we are going to do is we are going to expand this we have here. Well, if you begin to understand this whole process, you realize that you don't necessarily even need to expand it all. You see, you need to just expand such that, since now it is b we want, we would expand such that we have an equation in terms of b and then solve for b. So expanding, we have our x plus 3, which is equal to a into bracket x plus 2 all squared, gives us an x squared plus a 4x and then plus a 4. Then we have plus the b. So b multiplies, if you have x minus 1, that is multiplying x plus 2. If you want to expand that, we are going to get x times this whole bracket, which gives us an x squared plus 2x, then minus x minus 2. Simplifying further, we have x squared plus x minus 2. You see, so that is what we are going to substitute in here. X squared plus x minus 2. And then plus that of the c can simply be evaluated. So we have cx minus c. So how do we form this equation I'm saying would help us solve for b? If you have to group like terms, we have x plus 3. Even before grouping like terms, we can say we have what? An ax squared. That is a times x squared. Then we have plus 4ax. That is a times 4x. And then we have 4a. Then plus that of the b. So b x squared. Then b times x gives us plus a bx. And then b times negative 2, we have a minus 2b. Then if it comes to the constants, it just has a cx minus c. So if you are to group them all, we have x plus 3, which is then equal to, we have a plus b over here. They form the x squared. So we have a plus b x squared. And at this stage, you can even stop and then solve for your b, because you can develop an equation in terms of b over here. But let me take time to explain it all. Then plus, we have 4a plus b plus c, all with a coefficient of x. So plus 4a plus b plus c, all with the coefficient of x. And then for our constant terms, what do we have? We have plus 4a minus 2b, then minus c. So with this that we have, we can form an equation. The term we have on our left hand side actually has no values in terms of x squared. You see, and if you want it rewritten, we can rewrite it as a 0 x squared plus x and then plus 3. You see, so with that, equating the coefficient, we have 0 that will be equated to the coefficient of x squared. So we say a 0 is equal to a plus b. This is our equation 1. Then for those that have the x, we can say we have 1 here. So 1 is equal to 4a plus b and then plus c. That is our equation 2. And then for the constant terms, we have 3, which is equal to 4a minus 2b, then minus c. That is our equation 3. Since it is b we want to solve, let's take the minimum equation where we'll get the b. So we have 0, that is from equation 1. So from equation 1, we have 0 is equal to a plus b. And we know our a, which we have solved. And we know our a, which we have solved to be what? 4 over 9. So let's substitute that. It simply means 0 is equal to 4 over 9 plus b. And making b the subject, b is simply equal to a negative 4 over 9. You see, very simple, isn't it? So with this, we now come all the way back to our decomposition with it right here. And then we'll write our partial fraction. So it simply means our x plus 3 over the x minus 1, then the x plus 2 all squared can be rewritten as our a, which is 4 over 9 all over x minus 1, then plus the b, which is negative 4 over 9 all over x plus 2, then plus the c, which was negative 1 over 3 all over x plus 2 all squared. And this is rewritten as 4 over 9 into bracket x minus 1. Then since we have a negative here, it is going to affect this as well. So that we say minus 4 over 9 into bracket x plus 2. And this negative as well affect this negative, so that it affects this positive. So that we have minus 1 over 3 into bracket x plus 2 all squared. So this becomes a fraction, a partial fraction written in standard form. So as you have seen us solve, the beginning we have over here, that is all of this right here, was the cover-up method. The cover-up method in its expanded form, you see. And the cover-up method could not solve for a, b, and c. it was limited toward solving for only A and then C. Why? Because we can't cover up A and then C all together to solve for B. You see, then after the cover method giving us A and then C, we now used the expanded, the method of undetermined coefficient to solve for what? The B. So both methods go hand in hand when it comes to what? Case 2. To enhance our understanding, let's solve some few more questions, just about 2 of them. So this is our second question, and as you can see, it says 2x squared plus 3x plus 1 all over x plus 1 all cube, and we have to decompose it. In other words, you have to write it in partial fractions. We'll go through the same method we used for the previous one, after which I'll introduce to you another shorter method as well. So what we have our 2x squared, then plus 3x plus 1, and that is all over x plus 1 all cube. This time around, it is just one factor we have, but then it is repeated thrice. Hence, our partial fractions will be an a over x plus 1, that is the first factor to the first degree, then plus b over x plus 1 all squared, and then plus a c over x plus 1 all cube. So with this that we have, we can now proceed with the cover up method. So the cover up method, just as we did for the previous one, we expanded it. You see, we expanded and then we had our values. So at this stage, we can remove or clear our denominators. You see, and clearing our denominators, which we are now conversant with, we just write the numerator of this first one, which is 2x squared, then plus a 3x, and then plus 1. And that will be equal to a into bracket. This is x plus 1 all cube. All cube simply means it is multiplying itself thrice. So this one would at most cancel just one of this, and we'll be left with what? A squared of it. So a into bracket x plus 1 all squared, then plus b into bracket x minus 1 all squared simply means it's going to cancel two of these ones. We'll be left with just one of them. So x plus 1, and then plus c. The c is all cube. So with that, it cancels everything over here, and we're left with 1. So we have c times 1, which gives us our c. So at this stage, we now want to what? Solve for any of the variables. Now, using the cover up method, we can easily cover up all these two. That is the a and then the b. We'll do that by substituting x to be -1. So we would say let x to be equal to -1. The reason why we are using -1 is if you're able to use -1, we have x -1 plus 1 giving us 0. And 0 times a would give us this whole term being 0. Same applies to this whole term. We'll get a 0, and then we'll be left with just the c. So with that, we have our 2 into bracket, substituting x to be -1. We have -1 all squared, then plus 3 into bracket, -1, then plus 1, which is equal to, as all of this gives us 0, we have our c. Evaluating, we have 2 times 1. 2 times 1 gives us 2. Then plus 3 times -1, that gives us a -3. And then plus 1 is equal to c. So this is to say c, 2 minus 3, which is a -1, plus 1. That gives us our c, which is equal to 0. So now that we have our c to be equal to 0, the next thing we can do to solve for the remaining is to expand. we'll have to expand this line over here. And by expanding, our left hand side still remains 2x squared plus 3x and then plus 1. By the right hand side, we have a into bracket x plus 1 all squared gives us an x squared plus 2x and then plus 1. Then plus the b times all of this gives us a bx plus b, and then we have our plus c. So expanding this bracket as well, we have our 2x squared plus 3x plus 1, which gives us a times x squared gives us an a x squared, and then a times 2x gives us a 2ax. A times 1 gives us an a, and then plus bx plus the b, and then plus c. Now you would want to group like terms at this stage. So we still have our 2x squared, then plus 3x plus 1, which is equal to, looking at all those that have x squared, it is just a. So we have a x squared plus all those that have the x. There is a 2a that is from here, and then there's also a b. So plus b with our x. Then for the constants, we have a plus b plus c. That is a plus b plus c. So equating the coefficients for those with x squared, which is just a, it simply implies 2 is equal to a, right? Or a is equal to 2. This is our equation 1, which is even just a simple one, which gives us an answer. Then for those of the x's, we have 3 is equal to 2a plus b. There's our equation 2. There will be no need going there for equation 3 because we have our a and we already know our c. So let's put a into equation 3. And this would imply that our 3 is equal to 2 into bracket a, which is 2, then plus b. Making b the subject, we have 3 here, then minus 4. That gives us our b, which would be equal to a negative 3 minus 4, which is 1. So this simply implies that, or we say therefore our a is equal to 2, our b is equal to negative 1, and then the c is equal to 0. So if you want to substitute into our decomposition formula, then it simply means 2x squared plus 3x plus 1 all over x plus 1 all cube is going to be equal to our a, which is 2, over x plus 1, then plus our b, which is negative 1, over x plus 1 all squared, and then plus our c, which is 0 over x plus 1 all cube. If we then want to rewrite this, then we would simply have our fraction, which would be equal to the 2 over, we have x plus 1, then because of the negative, it comes right here. So I have 1 minus x plus 1 all squared, and then there will be no need bringing the 0 because 0 over anything is still 0. So you should notice that the term with the x plus 1 or to the power 3 vanished because the c is what? Equal to 0. Now, one thing you should note is that you would get a constant to be 0 most of the times if the denominator you have has a factor in the numerator. What do I mean by that? We have our 2x squared, then plus 3x plus 1. That is all over x plus 1 all cubed. If you have to rewrite the numerator, we'll get, you have to factorize it, you get a 2x plus 1, then into bracket x plus 1. I do want to believe you know how to factorize your quadratic functions. So we have x plus 1, and then x plus 1, and then an x plus 1. So with that, this x plus 1 takes out one of the x plus 1s. So that will be left with a 2x plus 1 all over x plus 1 all squared. You see, so this is what led to we cancelling out, or the term in x plus 1 cube vanishing, because in natural sense, if we simplify, it doesn't even exist over there. Initially, I said I would take us through a shorter method we can use to obtain the same answer. It is not a traditional method, but then it is very, very simple. Now, for this method I'm about to explain, we only use it if you have just one factor and it keeps repeating. You see, if you have, let's say, a single repeated factor, you might have x plus 1 all cube, or 2x, anything at all. Let's say x plus 1 all squared, and that is the only factor you have in the denominator. It is best you use this one. It is a very, very short method. So what it says is, we first of all define a variable. So we say let u be equal to x plus 1. This x plus 1 is actually taken from what? The repeated factor. You see, so if u is equal to x plus 1, then it will imply that, making our x the subject, our x is equal to u minus 1. So with this u minus 1 you have as your x, you substitute it into any value of x you have here. So that is to say, let's substitute x equals u minus 1 into the numerator. And that will mean, instead of our 2x, the x now becomes u minus 1 all squared, then plus 3. Instead of x, it becomes u minus 1. Then we have our plus 1. Then we can now simplify this. We have our 2 into bracket u squared minus 2u, then plus 1. Then plus your 3u minus 3 plus 1. If you have to simplify all of this, you are going to get a 2u squared minus 4u plus 2, and then plus 3u minus 3 plus 1. Grouping like terms, we have our 2u squared, that is from here, then minus 2u plus 3u, then gives us a negative u, then 2 minus 3 plus 1 gives us a 0. You see, so with this, it simply means that this whole fraction we have over here has been rewritten. The numerator has been written as this in terms of u. So we have 2u squared minus u, then all over the denominator. We said x plus 1 is u, so this is our u here. So u cube, that is u cube. You see, so with what we have up there, which is 2u squared minus u all over u cube, if we want to split the fractions, you know, we can rewrite it as 2u squared over u cube, then minus u over u cube as well. That is, the denominator is being distributed to both numerators. That is, this numerator here takes the denominator, and this numerator also takes the denominator. So with that, if we are to simplify, we have 2 of the u's here, reduce this by 2. So that we'll be left with what? A 2 over u minus 1 of this u will reduce this also by 1. And we'll be left with a 1 over u squared. So we can now come all the way and then say we have our 2 over, remember what we said u was. U we have over here is simply what? X plus 1. So we have 2 over x plus 1, then minus 1 over u squared, which is x plus 1 all squared. And that is equal to our function we were given over here, which is the 2x squared plus 3x plus 1 all over the x plus 1 all cube. And you realize that if you are to compare that to what we have right here, it is the same thing. You see, it is the same as what we used our expansion and substitution to solve, right? So this is a very quicker or faster method. We use, that is, if and only if your denominator is a repeated factor. You see, we use the method of substitution. Nonetheless, you can stick to the previous method and you'd be fine. So let's look at our last question we have here, which says we have 2x plus 1 all over x plus 2, then x plus 1 all squared. Now, how are we going to go about it? This time around, I'll try and then apply the cover-up method we learned in case 1, so that I see how that would also work. We know if you are to write our decomposition formula, we have a 2x plus 1 all over an x plus 2, and then an x minus 1 all squared. Now that is equal to a over x plus 2. And then we have our b over, this is where we have the repeated factor. So b takes one of the repeated factor, then c also takes the repeated factor to the power 2. So with this, using the cover-up method, if you want to solve for our a, then we'll say our a is equal to, remember for the cover-up method, we take this whole function we have here, its numerator, that is 2x plus 1 over all the other denominators, excluding what a has. So with that, we have what? X minus 1 all squared, but then we'll evaluate it. So we are going to evaluate it at x equals the value that makes a's denominator 0, and that is a negative 2. So evaluating it, we have 2 into bracket negative 2 plus 1 all over negative 2 minus 1 all squared. That is our a. And simplifying further, we have 2 times negative 2, which is a negative 4. Negative 4 plus 1 gives us a negative 3. Then we have negative 2 minus 1, which gives us a negative 3. Negative 3 squared gives us a 9. Hence, our a is equal to negative 1 over 3. Now, if we want to solve for b, we can't solve for b. The reason being that if we are to write the denominator, we would have to exclude what we have in b, which is x minus 1. That reduces this by 1. But here still it appears again because there are 2 of the x minus 1. Hence, we can't use the cover-up method to solve for b. That is its limitation. So let's go to c and then c. So for c, we have the numerator, which is 2x plus 1, then all over the denominator, but then excluding c's denominator. That is x minus 1 all squared. So you are left with what? X plus 2. And we are evaluating it at the value at which x denominator gives us what? 0. That is x. And we are evaluating it at where we have c's denominator equals what? 0. And that is an x is equal to 1. Hence, we have our c, which is equal to 2 into bracket 1 plus 1 all over 1 plus 2. Our c gives us 2 times 1, which is 2. 2 plus 1, we have a 3 all over 1 plus 2, which is also a 3. Hence, c equals 1. So with the cover-up method, we've been able to solve for a and then c. But we need our b. Hence, we need to expand again to solve for what? B. So with that, right from this point, we'd have to eliminate all our denominators. We clear them off so that we have 2x plus 1, which is equal to a into bracket. A takes out x. That is x plus 2 takes out x plus 2, and we'll be left with what? X minus 1 all squared. At this stage, we know what that will give us. So let me just write it as x squared minus 2x and then minus 1. Then plus b also takes out 1 of the x minus 1. That is b's denominator. It will be left with a b into bracket, an x plus 2, and then an x minus 1. Then we have plus our c, which also takes out this. And then we would be left with what? Into bracket x plus 2. Now, if we want to evaluate what we have here, we'll be getting x into bracket x minus 1, then plus 2 into bracket x minus 1. That gives us an x squared minus x, then plus 2x minus 2. Simplifying further, we have x squared plus x minus 2. So instead of all these we have here, I'm just going to substitute that with what? Into bracket x squared plus x minus 2. Now, the only thing we need to do here is to get an equation in terms of b so that we can solve for the b. Looking at it carefully, b has an x squared, a has an s squared, and we have 0x squared over here. So we can say 0x squared is equal to a times x squared, which is a x squared, plus b times x squared, which gives us a b x squared. Simplifying, we have 0x squared, which is equal to a plus b with our x squared, which implies 0 is equal to a plus b. You already know the value of a, you see. So substituting it, we simply say 0 equals negative 1 over 3 plus b. And making b the subject, it simply implies that our b is equal to a 1 over 3. So with that, we can now substitute and get our partial fractions. It simply implies we have a 2 plus 1 all over x plus 2, then x minus 1 all squared. And in partial fraction, that gives us our a. A, we said, was what? By now, we know how to write them straight away. So a being negative 1 over 3, we have negative 1 over 3 into bracket x plus 2. Then our b on the other hand is a 1 over 3. So plus 1 over 3 into bracket x minus 1. And then our c was what? 1. So you say plus 1 over x minus 1 all squared. This becomes the partial fraction representation of our compound fraction we have over here. I would like to end this lesson right here, but as usual, I'll leave you with some exercises so you try on your own just to test your understanding. So here you have just 5 questions based on all that we've done so far for you to try to enhance your understanding. Let's have your numbers so you learn maths the easy way. If there's any issue of concern, you can always let me know at the comment section. If this is your first time on this channel and you think it will be of help to you, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson. In our next lesson, we'll be looking at case 3. Bye for now and stay safe.